The narrative begins with the mechanical redemption of an aircraft that was never supposed to exist in its final form. We dive into the Avro Lancaster scandal of 1939, exploring how the original twin-engine design was a catastrophic failure due to its unreliable Vulture engines, which were prone to catching fire mid-flight. We analyze the illegal pivot made by chief designer Roy Chadwick, who bypassed traditional bureaucracy to take the failing Manchester airframe, stretch the wings, and bolt on 4 legendary Rolls-Royce Merlin engines. This desperate engineering gamble transformed a suicide trap into the most capable heavy bomber of the European theater. Then we break down the physics of the bomb bay, a unique design feature that set the Lancaster apart from its American peers. Unlike the B-17, which had internal structural bulkheads dividing its payload, the Lancaster featured a massive, unobstructed 33-foot-long bay. We examine the forbidden payloads this allowed, from standard incendiaries to the monstrous Tallboy and Grand Slam earthquake bombs that no other aircraft in the Allied arsenal could physically lift. We detailed the symmetry-breaking moment of the Lancaster's first flight in 1941, where it immediately proved it could carry double the bomb load of any other bomber while maintaining the agility of a much smaller plane. The segment concludes with the industrial miracle of its mass production. We look at the factory audit, showing how over 7,000 units were built across the UK and Canada, turning a failed experiment into the backbone of RAF Bomber Command. We reflect on the genius of simplicity, how Chadwick's modular design allowed for rapid repairs in the field, ensuring that even a battered Lanc could be patched up and sent back into the night sky within hours.
This segment explores the symmetry-breaking strategy of RAF Bomber Command, which turned the night sky into a battlefield. While the Americans opted for high-altitude daylight precision, the Lancaster became the undisputed king of acoustic terror under the cover of darkness. We break down the electronic warfare suite, the introduction of window, bundles of aluminum strips to effectively blind German Würzburg radar, and the H-2S ground scanning radar, a forbidden technology that allowed navigators to see the shape of cities through thick cloud cover and total darkness. We then dive into the crew's psychological toll. For 7 to 8 hours, 7 men were trapped in a freezing, unpressurized metal tube, vibrating with the roar of 4 Merlins while being hunted by Nachtjacht aces equipped with upward-firing Schrager-Musik cannons. We analyze the mechanical durability of the airframe. The Lancaster was built with a rugged, multi-spar wing design that allowed it to sustain illegal damage. We detail harrowing flight logs of Lancasters returning to base with entire tail sections shredded by flak or engines sheared off, proving that the accidental masterpiece was as tough as it was heavy. The section concludes with the Pathfinder technique, the high-stakes coordination between the Lancaster truckers and the elite pilots who dropped colored flares to mark targets. We look at the industrial grind of the Battle of the Ruhr, where the Lancaster's ability to carry a mixed bag of high explosives and incendiaries began to systematically dismantle the heart of the German war machine, one midnight sortie at a time.
The finale explores the kinetic siege era, where the Lancaster transitioned from a traditional carpet bomber into a platform for illegal precision engineering. We begin with a 5-minute technical breakdown of Operation Chastise, the Dambusters. We analyze the symmetry-breaking physics of the upkeep bomb, a 9,000-pound cylinder that required a specialized hydraulic motor to spin at 500 RPM backwards before release. This forbidden backspin allowed the bomb to skip over anti-torpedo nets, using the Magnus effect to hug the dam wall as it sank, ensuring a hydrostatic detonation that used the water's own density to shatter the concrete. We then transition into the subterranean ballistics phase, focusing on the two most terrifying payloads of the war, the 12,000-pound Tallboy and the monstrous 22,000-pound Grand Slam. We analyze the physics of the earth shock. Unlike standard bombs that exploded on impact, these were designed with high-tensile steel casings to survive a supersonic terminal velocity and penetrate up to 100 feet into the earth. The resulting underground explosion created a camouflet, a localized cavern that caused a man-made earthquake, collapsing invincible reinforced concrete submarine pens and railway viaducts from the foundations up, rendering traditional armor useless. The narrative spends significant time on the logistical extremes required to field these weapons. We examine the Lancaster BI Special, an airframe so burdened by the 10-ton Grand Slam that it had to be stripped of its nose turret, mid-upper turret, and heavy armor plating just to get off the runway. We detailed the sinking of the Tirpitz, where the Lancaster's stability allowed it to act as a sniper platform, dropping Tallboys from 14,000 feet with such precision they capsized a 52,000-ton battleship in a single afternoon. The segment concludes with the forbidden legacy of the Lancaster. We look at its role in the Berlin airlift and how its massive lifting capacity redefined aerial power for the Cold War. We reflect on the cost of the night, the staggering 44% attrition rate of the crews who flew this midnight trucker. The final shot is a slow-motion study of a Grand Slam impact, symbolizing the moment the Lancaster stopped being a plane and became a force of nature.